Good evening, students. Now already we have started the chapter Is Matter Around Us Pure? In that I have told you what is pure substance, impure substance. In pure substance I have explained you elements and compounds. In mixtures, impure substance, I have told you about mixture. In that also I have told you what is solution, suspension and colloid. I have given you few examples also in previous class. For solution, like I've given you example of sugar in water, salt in water. Then for suspension, sand in water. And for colloid, I've given you example of milk. I've told you that colloidal look like homogeneous mixture, but it is actually heterogeneous. Now, in that class, I have explained you what do you mean by homogeneous and what is heterogeneous. Homogeneous means uniform composition and heterogeneous means non-uniform composition, or we can say that we can easily observe the different components of that particular mixture. Now, in this session, we are going to study in detail about solution. Now, solution is component of two types, solvent and solute. Okay, it is made up of two components, solvent and solute. Solvent, I have told you, which is in which solute is dissolved, and solute is which is dissolved. Okay, like sugar and water, sugar is solute and water is solvent. So, what is the main feature of solution? See, solution is a homogeneous mixture. Okay, it is a homogeneous mixture. Its particles, solute particles, are smaller than 1 nanometer in diameter. Okay, so solute particle is smaller than 1 nanometer in diameter, and that's why it is so small. That's why we are not able to see solute particles with our naked eyes. Like once we have made the solution of sugar and water, we will not be able to identify sugar solution separately because it gets completely dissolved. So that's why we are not able to observe by naked eyes. Next is, it do not show Tyndall effect. It does not show Tyndall effect. That is, it does not scatter light. Okay, it does not scatter light. Now, why it does not scatter light? Because particles are so small that light passes through it. Okay, so light does not get scattered. That's why solution does not show Tyndall effect, while suspension till the solute particles are moving, till that part it will show Tyndall effect. Once the particles are settled down, suspended in the solution, then it will not show Tyndall effect, while colloidal, they show Tyndall effect. So when you are going to study the properties of all these solutions, suspension and colloidal comparatively. So it will be easy for you to write the differences and even study the different characteristics or features of all these three types of mixtures. Now, like I told you, solution is homogeneous. So suspension and colloidal are heterogeneous. But again, there is difference. Particles of suspension is very big. Okay, and it can be seen by naked eyes. Like we can easily see sand particles. Okay, so it can be seen by our naked eyes. And we can say that it is unstable. Okay, it is unstable. Why it is unstable? Because once I am dissolving sand in water, what will happen? It will move in water for a few minutes. Once I have kept that beaker in which I have added sand and water, if I am not touching it, after a few minutes, the sand particle will get settled down. So it is unstable. While solution and colloid are stable. Solution and colloid are stable. Clear? Now, next thing is colloidal. It seems to be homogeneous, but it is heterogeneous. That I have told you previously also. Like I have given the example of milk. In milk, we are not able to observe solute and solvent particle. In colloidal, it is termed as dispersion phase and dispersion medium. So, we are not able to identify, but it is a heterogeneous mixture. Okay? And it will show Tyndall effect. Okay? It will show Tyndall effect. See, what happened? Suspension is heterozygous and it is unstable. That I have told you why it is unstable, because particles get settled down at the bottom. It gets settled down at the bottom after keeping for sometimes. While colloidal remain as it is, it does not get settled down. So we can say that it is stable. Now in this colloidal, particles are small than suspension, but it is bigger than solution particles. That's why it is continuously moving. And when we pass the light, and when light is passed through colloid, what happened? Particles are there. So it strikes the particle and it gets scattered. That's why we are able to see the path of light. Or we can say it shows Tyndall effect. Clear? Now, in solution, it is of different types depending upon, first we can say physical state. Physical state of solute and solvent. If both solute and solvent are solid. First type is solute and solvent both are solid. We can take the example of alloy. Now second is if solute is solid and it is dissolved in liquid. Okay. So solid in liquid, like just now I have given the example sugar solution. Next is liquid and solid. Means liquid is dissolved in solid. It is also possible like hydrated salt. Salts in which water molecules are present are termed as hydrated salt. So these are which type of solution? Liquid and solid. Next is liquid and liquid. Liquid and liquid means any two liquids are mixed together. One is taken in small amount, another in large amount. Like alcohol and water. Next, fifth one is gas and liquid. Like you take aerated drinks, cold drinks and all. As soon as bottle opens, a gas is released. That is solution with gas in liquid. Next is solution of air and, or we can say mixture of gas in gas, that is air. Okay, different types of gases are present in air which are mixed together and we are not able to identify each and every gas. So these are the different types of solution depending upon its physical state. Now next we can say it can be based on the amount of solute dissolved in given solvent. Amount of solute in given solvent. Means if I taken 1 glass water, how much sugar or how much salt I have added in that. On that basis, we can differentiate or we can classify it in two types, that is saturated and unsaturated. Saturated means no more further solute can be added. Means if I have taken 1 glass water and in that I am adding sugar. So one condition will come when further if I am going to add sugar, it will not dissolve. It will get settled down. That state is known as saturated. And if I have taken 1 glass and I have only added 1 spoon sugar, then further more sugar can be added. It means less amount of solute is taken, so it will be unsaturated. Next type of solution is depending upon the amount of solute in solution. Okay, if in a solution very little amount of solute is added, then it is termed as concentrated. Or we can say amount of solute is more, then it is concentrated. Amount of solute is less, then it is dilute. Okay. In lab we are diluting the different solutions. On that basis only it is written concentrated or dilute. So these are the different types of solution. Now what about suspension and colloid? Now in suspension no further classification is done, but in colloid same on the basis of as we obtain in solution, on the same basis colloidal are also different type. Like we can say aerosol. Aerosol means solution of or mixture of gas and liquid. Okay, mixture of gas and liquid like fog, mist. These are mixture of gas and liquid. Now next can be solid and gas. Mixture of solid and gas. That mixture of solid and gas is also known as aerosol only. Okay, so that is smoke. We are seeing mixture of gas and solid, dust particles. All these are, or we can say exhaust coming out from their vehicles or industries. That will form mixture of solid and gas. That will be aerosol. Now other can be gas and liquid like foam. Okay, gas and liquid like shaving cream and all. Next is liquid and liquid like milk, creams. That will be type of colloid in which liquid and liquid is taken. Both dispersion phase and dispersion medium is liquid. Now next is if I have taken dispersion phase as solid and dispersion medium as liquid, it means solid and liquid. For that we can take the example of milk of magnesia. Milk of magnesia in which we have taken solid and gas. Even starch also, solution of starch also is solid and liquid. Then is gas, solution of gas in solid, gas in gas. So these are the different types of colloidal solution. These are the different types of colloidal solution. Now, how many types of mixtures we have studied? Homogeneous, heterogeneous, solution in homogeneous, and in heterogeneous suspension and colloid. We have discussed the properties of these mixtures. We have done the comparative study also about solution, suspension and colloid. We have studied different types of solution depending upon its physical state, amount of solute, and after that we have done different types of colloid depending upon the dispersion medium and dispersion phase. Clear? So in next we are going to do the separating techniques. See, mixture, it means it has impurities. So that impurities should be removed. Okay, for that we are going to use different separation techniques. Now here also we can say, see, solution, once the sugar solution is prepared, we will not be able to separate it by filtration. So it cannot be separated by filtration. It can be separated by evaporation, crystallization. Suspension, bigger particles are there, so it can be easily separated by filtration. Okay, for suspension it is easy to use filtration. Now next is colloid. Colloid, also particles are small, so it cannot be separated by filtration, but it can be separated by centrifugation, like butter from the milk. In dairy farms and all, they are using centrifugation method to separate butter from the milk. So these are the different methods which we are going to discuss in next video.